We're going to take a look at the normal curve and calculating z-scores on the standardized normal curve. So the normal curve is a symmetrical distribution with a single peak in the middle. It's also called the bell curve. It represents a lot of things in nature that share this type of distribution. One thing, for example, would be height. Another would be standardized test scores, or IQ scores will often follow a distribution like this. And there's countless examples of things in nature that follow a normal distribution, where there's a lot of things clumped up in the middle near the mean, a few that are smaller, a few that are larger. When you were looking at the standard normal curve, the standard normal curve is going to have a mean of 0, so the center value is going to be 0. And each of these marks here represents one standard deviation. So if we go to the right, we're going to go up to 1 standard deviation, up to 2 standard deviations, and so forth. In the other direction, we're going to go back, so we're going to have -1, -2 as the value on the standard normal curve. Now it looks like this goes to 0, but it does in fact go on forever. Just the area under the curve would get very, very small as we get farther out. So now let's take a look at a problem where we have a standardized test with a mean score of 600 and a standard deviation of 40. Whenever you have a mean score, you're going to go ahead and plot that right in the middle, right where we have the 0 on the standardized curve. You're going to put the mean right in the center. Now the standard deviation allows you to count upwards or count downwards from the mean, so that at each of these tick marks here that represent one standard deviation, you can write in a score. So we're going to go from 600 to 640, and then to 680, and then the same thing the other way down to 560 and 520. We're subtracting or adding a standard deviation at each of these marks. And so far we haven't been asked a question. We were just sketching out the distribution so that we knew what we'd be working with. We had a good picture to work with no matter what the question was asking. Now it asks, how many standard deviations from the mean are you if you score 680? And then what is your z-score? Well, if you get a 680, we can go ahead and mark that on the picture here. And if you look at it, we're 2 tick marks away from the mean. So we are 2 standard deviations away from the mean. Now, your z-score is just the number of standard deviations you are from the mean, so our z-score is going to be a positive 2. If we take a look at the definition here, the z-score is the number of standard deviations from the mean, just like we talked about. If you prefer a formula as opposed to counting like we did just there, something like this might be very helpful. The z-score is equal to x, which is the value that you're given, minus mu, which is that U shape here, and that stands for the mean, divided by sigma, the O shape, and that represents the standard deviation. So if we uncover this and we look back to the example that we just did, let's go ahead and try to calculate it using the formula. Z is going to be equal to x minus mu over sigma. X is that value that we care about, the value we are given. So that will be 680, and we'll write that in here. We're going to subtract out the mean of 600. And then we're going to divide through by the standard deviation, in this case 40. So if we do our numerator first, we're going to get 80 on top. So we're going to have our standard deviation of 40 on the bottom. And 80 divided by 40 is 2, just like what we got when we did it on the graph here. So our z-score is 2. And that makes sense because our number is greater than the mean, and it's 2 standard deviations greater than the mean. Finally, let's take a look at working backwards. So if you were to take this formula here and use some algebra to solve for x, you multiply both sides by sigma, and then add the mean to both sides so that you're left with x alone on one of the sides. And that's what this formula is just using some algebra on this. Let's imagine a new problem. So here's our question. You score 3 standard deviations below the mean. what was the score that you actually got on the test. So when you talk about 3 standard deviations below the mean, what you're referring to is a z-score. The z-score is the number of standard deviations. So our z is going to be equal to -3. It's below the mean, so -3. And the other values are given to us. So if we go ahead and pop those in together, we're going to have our mean 600 plus our -3 times our standard deviation of 40. And we're going to get 600 minus 120, which is going to come out to 480. So our score is going to be 480 points on this test.